Okay. So good morning, everyone. So welcome all to today's WEM seminar. So time really flies. This is really, I don't expect that this is already the fifth time of our seminar series. So I'm very happy to be here to act as a host, the usual face today, to moderate the WEM seminar series number 5. So today we were expecting a lot of alumni from our WEM family who will be joining us today. So we're very happy to welcome them to this initiative to share knowledge and to show the activities that are going on, from our generation. So for today's seminar, we'll be having the presentation of Ms. Prakya. So Ms. Prakya is currently a PhD student of our Water Engineering and Management program. Her research interests include climate change impact assessment, hydrological modeling, and artificial neural network. And Ms. Prakya will be here to share with us one of her research on evaluation of soil and water assessment tool and artificial neural network models for hydrologic simulation in different climatic regions. So following up, the second presenter for today's seminar would be Ms. Parijat Prinsri. She actually just graduated from a water engineering program as a master. So I'd like to say congratulations to Ms. Prinsri. And Ms. Prinsri's research interest includes groundwater resource assessment, climate change, land use and land cover change, hydrological modeling, and groundwater modeling. So coming to this WEM seminar today, Ms. Parijat will be sharing her research on assessing climate change, land use change, and abstraction scenarios impacts on groundwater resources in the Special Economic Zone of Thailand. So before we start our usual agenda, I would like to invite Professor Sangam, who will be sharing a short video clip to spread the congratulations, exciting vibe for everyone. Okay, so please, I will pass the platform to Professor Sangam. Please, Professor Sangam.
Good morning, everyone. I think this is not in the plan, but we have prepared a short video of our graduates in 2021 who are explaining about their research, what they have done in their master's and PhD thesis. So it's about 5 minutes. So I get permission to play the video. Yeah.
In our program, students conduct their research toward understanding the complexity of water cycle, water use and its management in the face of global challenges such as climate variability and climate change, rapid population growth, urbanization, pollution and damming of the rivers. This year, 14 students have graduated from our program. They have conducted their research by employing innovative approaches, advanced tools and techniques to formulate sustainable solutions to water problems at various spatial and temporal scales. Let's learn about the research from them.
My study illustrates the impact of climate change on water resources and seawater inclusion in 𝐾𝐬𝐬𝐥, Thailand. The results indicate that during the 21st century, temperature is increasing, rainfall and snowfall trends are fluctuating, and sea surface level is rising. This may increase the severity of seawater intrusion in lower Bamako River.
In my master's thesis, I estimated the impacts of climate change, land use change, and obstruction scenarios on the groundwater resources in Siem Reap in Cambodia. It was found that in the future, groundwater level will decrease near Angkor Wat and the city center. The results of this research will be helpful in the sustainable development and management of groundwater resources in Siem Reap, Cambodia.
I estimated the impact of climate change, land use change, and population growth scenarios on groundwater in Tak Special Economic Zone of Thailand. I found that the impact on groundwater is different in different locations. Structural and non-structural adaptation measures should be implemented in Tak Special Economic Zone to offset the negative impacts.
I have used the physical modeling to study the flow characteristics of asymmetric approach channels and propose a good alternative for asymmetric approach channels. The results show that the main factor affect flow characteristics are the angle and the width at the entrance of approach channel. The findings of my research can use with the hydropower projects that are developed in the small river.
I used a remote sensing-based gravity recovery and climate experiment that is GRACE dataset to detect groundwater storage change in Cambodia. It is found that over the last 15 years, from 2002 to 2017, groundwater storage in Cambodia has been decreasing with a rate of 7 mm per year. Given this depletion, effective measures should be implemented to manage the groundwater resources.
Yeah, thank you, Dr. Locke. Yeah, so please proceed.
Yes, thank you, Professor Sangam, for very inspirational videos. Actually, I was a student here, but I didn't have this kind of experience before. So really, great appreciation to Professor Sam for putting this together. So we'll be coming back to our usual agenda. May I invite Ms. Pragya to start sharing her screen and then start our today's seminar. Please, Ms. Pragya.
Thank you, Doctor. Thank you, sir. I will start sharing my screen. Good morning, everyone. My name is Pragya Pradhan, and I'm a PhD student in water engineering and management. I would like to welcome you all in today's webinar. I'm going to present today on my master's thesis on the title, The Comparison of Physically Based Rainfall Runoff Model SWOT with the ANN model in different climatic regions. My presentation begins with the outlines, and they are research background, objective and scope, study area, data and methods, result and discussions, and following with conclusions. As we all know that there are different variables of the hydrologic cycle, and like rainfall, stream flow, groundwater, evapotranspirations, and many more. Among all of them, the stream flow is one of the most important variable of hydrologic cycle. For the planning, management, forecasting of the water resources, different kinds of hydrological models are used. Hydrological models are very effective and friendly user, and mainly depends upon the high quality and quantity of data. In different kinds of the hydrological models, physically based hydrological models is the one which is mostly used to solve different kinds of the hydrological problems since past decades. Like the hydrological problems like a flood, flash flood, landslide, soil erosion, drought, problems related to groundwater are mainly solved by the physical based hydrological model. As a physical based hydrological model is highly dependent upon the availability of data. If the data are not available due to lack of cost or lack of time, then it directly affects to the results and leads to the model uncertainties and unsatisfied performance. And nowadays, like artificial intelligence techniques have been used as alternative to physical-based hydrological model. Artificial intelligence techniques are more popular and efficient because of its effective for solving different kinds of hydrological problem using relatively less cost, time, and effort. And there are different kinds of artificial neural, like artificial intelligence tools like artificial neural network support vector systems, which are very popular and efficient for solving hydrological problems. And moving forward to objectives and scope, the main objective of the study is to evaluate and compare the performance of physical-based model with a suitable artificial neural network model in different climatic regions. The scope of my studies are the study of different climatic zones. They are like tropical, subtropical, and semi-arid. The study and use of the soil and water assessment tool SWOT and SWOT curve for the model calibration and validation of different basins. And the study of artificial neural network and model and its type like a multi-layer perceptron, general regression neural network, and feed-forward backward propagation using MATLAB. In this slide, this is the location map of my 3 different river basins. As my study area covers the 3 different climatic regions of the Asia. First one is the Haridwar River Basin, which represents the semi-arid climatic zones from Afghanistan. Second is Shepok River Basin, which represents the tropical climatic zones from Cambodia. And the third one is the 𝐶𝐶 River Basin, which represents the subtropical climatic zones from Nepal. The basin area of 𝐶𝐶 River Basin is 7,438 kilometers square, whereas Shepok the Shepok is of around 12,780 kilometers square, and of the Haridwar River Basin, it's around 21,124 kilometers square. And other physiographical characteristics of these 3 river basins we can see in this table number 1. Further moving on, this figure shows the methodological framework of for the evaluation of SWOT and ANN model for hydrological simulation in different climatic regions of Asia. At first, this mainly study is based on the comparison of 2 different kinds of model. First one is the physically based hydrological model, that is SWOT, soil and water assessment tool, and second one is the artificial neural network model. For the physical based hydrological model, we need hydrological data, meteorological data, geospatial data. After that, the model was set up in SWOT, and then the calibration and validation of the model was carried out. Then we get the simulated runoff. After similarly for the artificial neural network, for this 3 different kinds of the models were used. One is feed-forward backward propagation, multi-layer perceptron, and general regression neural network. And the input data sets for the ANN are only rainfall and temperature. The model was set up in the MATLAB. Then the training and calibration and validation of the model was carried out. And after then, we get this simulated runoff from the artificial neural network model. After getting both of the simulated runoff from both of the model, the models were evaluated based on the statistical performance indicator and hydrological indicator. And after that, after the comparison with the two different indicators, it is again compared within the segments of a flow through flow duration curve, by which we get the best model for specific climatic region. Further moving on, this table shows the summary of the data that is used in the study. As in the previous slide, I've told that for the artificial neural network model, we only need two kinds of data sets, that is rainfall and temperature. But for the simulation of the physically based hydrological model, we need very different kinds of data like topographic data, land cover map, soil map, meteorological data, and hydrological data. And this table shows the sources and duration of all the data for all three different river basins. Further moving on the next slide, this slide, as I told before, that for the input of the ANN model, we need only two kinds. One is rainfall and temperature. And for the while setting up the ANN model in the MATLAB, we can give different kinds of combinations. Different kinds of combinations of input, and for this study I made around different four kind of input combination, and this figure shows the ANN network architectures using this data inputs. The first one is of input sections of the average daily precipitation, the second one is of average daily precipitation and average daily maximum temperature. The third combination is of average daily precipitation, average daily maximum temperature, and average daily minimum temperature. Whereas the fourth input combination is of daily precipitation of all station, daily maximum temperature, and daily minimum temperature of all station. We can make different kinds of combinations while preparing, while we need to train and validate the model. And for this model, I have used these fours. And after you for the ANN model, we have to make input layer, hidden layer, output layer, and for the input combination that will help to give the output that is simulated discharge. Further moving on the next slide, after both of the models were compared using the different evaluation criteria to compare the performance of the model. The first one is Nax-Sutcliffe efficiency. Second is RMSE observation standard deviation ratio. Third is coefficient of determination. Fourth is percentage bias, and fifth is normalized square. In this table shows the classification of performance of statistical performance indicator. For example, if my model NSE value is from 0.75, between 0.75 to 1, then the performance of the model will be classified as a very good. And further moving on to the result and discussion part. This figure shows the comparison of the observed and simulated ANN and the SWAT daily discharge hydrograph at the Gopaghat discharge station of 𝐻 River Basin, Nepal. The calibration period was from 1999 to 2005, whereas the validation period was of 2006 to 2008. In this table, we can see that the NSE value for the calibration period of a SWAT model was 0.77, whereas for the ANN model was 0.99 for the calibration period. And for the validation period, we can see that the NSE for the SWAT is 0.75, whereas for the ANN model, it's 0.98. If you're going to see in the figure, we can see that both the SWAT and ANN model simulates the discharge, but the ANN model better captures the peak and base flow as compared to the SWAT model. Further moving on the second figure, shows the observed and simulated ANN and SWAT daily discharge hydrograph at abandoned discharge station of Sherpok River Basin, Cambodia. The calibration period was from 2000 to 2003, whereas the validation period was from 2004 to 2005. the NAC from the SWOT for the calibration period was 0.78, whereas for the ANN models, the calibration NAC value is 0.97, and for the validation period, the NAC was 0.51, whereas for the validation of the ANN model, it was 0.99. In this also figure, we can see that both the ANN model and SWOT model simulated the observed discharge very well for the peak and base flow, but we can see that the ANN model have better captures the peak and base flow as comparison to the SWOT model. And the last figure shows the hydrograph at Taka Kaza discharge stations of Harihar River Basin, Afghanistan. In this figure, in this table, we can see that the NAC of a SWOT model is better than the NN model for the calibration period, with 0.59 for the SWOT model and 0.58 for the NN model. Further moving on for the validation, the NSC for the validation period was 0.52 and the NSC for the ANN was 0.65. In the figure, we can see that the SWOT model better simulates in the Harihar River Basin as compared to the ANN model. The ANN model has also simulates the discharge, but the values are very dispersed as compared to other basins. From the overall basin, from the overall figure, we can say that the ANN model ANN model is better for the subtropical and tropical region, but whereas the SWOT model have given a better performance for the Harihar River Basin, and we can say that the ANN model performance is better in the wet season, in a wet climatic zone rather than in the dry climatic zones. Further moving on to this slide. This slide shows the variability of a data through blocks plot in 3 different river basins. First one is for 𝐻, second is Shrapok, and third one is of Harihar. From the first figure, we can see that the observed discharge of average observed discharge of 𝐻 River Basin is around 50 meter cube per second, and the most and the models which have simulated the observed discharge, the general regression neural network, we can see that it have perfectly estimates the average discharge and the maximum value of the flow. And further moving on, in the Shrapok River Basin, we can see that all of the models, physical based model and artificial neural network model, perfectly simulates the average discharge and estimates the maximum flow. And for the Harihar River Basin, we can see that the variability of data in all of the models, like in a physically based model also and in the artificial neural network model also, we can see that the SWOT have overestimated the maximum values of observed discharge, but perfectly estimates the low values of the low value of the discharge. And further moving on, the model was evaluated based on the statistical performance indicator also, and it is evaluated based on the hydrological indicator also. The 4 kinds of the hydrological indicators was used. First one is annual discharge, second is Q wet, discharge in wet season, Q dry, discharge in dry season, and a base flow. For the both calibration period and a validation period, it is evaluated based on the percentage bias. If the model which have the least percentage will be classified as the best model for each hydrological indicator. Mainly this evaluation is carried out based on the hydrological indicator, because we want to see how the models perform in the different hydrological indicators. So we can specify the model according to the wet seasons and dry seasons. Like for example, if you're going to see for the Shrapok River Basin and for the 𝐻 River Basin, which is both tropical and a subtropical climate region, we can see that the ANN model performance are better in comparison to the SWOT model. And for the Haridwar River Basin, we can see that the SWOT model have a better performance for some of the indicators in compared to the ANN model for both calibration and validation period. Further moving on to the flow duration curve, the model was also compared based upon the different segments of the flow, like high flow, low flow, medium flow. The flow duration curve, there are three flow duration curves showing of three different river basins. First one is 𝐻𝐸 River Basin, second Shapok, and third is Haridwar. As the models are also compared on the basis of different flow segments, we can see that in a 𝐻𝐸 River Basin and in the Shapok River Basin, the general regression neural network model perfectly simulates the observed discharge in both 𝐻𝐸 River Basin and in a Shapok River Basin. Whereas if we're going to see in Haridwar River Basin, the general regression neural network model underestimates the high flow and overestimates the low flow in the Haridwar River Basin. Further moving on to conclusion and recommendation. The overall conclusion from my study is that suggests that the ANN models can be used with higher accuracy compared to SWOT in predicting high stream flow. The SWOT model simulates the prediction of a low stream flow values better than the ANN and provides knowledge of water balance components. The performance of ANN model decreases with an increase in non-linearity sense. It overestimates the low values of stream flow, leading to the complex non-linear relationship. For extreme hydrological events, forecasting ANN models are recommended for simulating the high flows and SWOT for low flows in the basin. The overall recommendation from my study is, as the study is based on the daily stream flow observed data, like daily stream flow models were evaluated. For the better evaluation, we can do the climate change impact on stream flow, and mainly the study is carried out in the upstream of the river basin. Further study can be performed on the whole river basin. Only three kinds of ANN models were used in this study. Further, the study can be carried out using other ANN models for better knowledge and results. As ANN models does not perform well in a dry climatic regions or arid region, further study can be focused on dry climatic region and its consequences. Further moving on, if anybody wants to have a detailed study in this topic, you can visit my paper, which was published in the Journal of Science of the Total Environment. And thank you for the listening.
Okay, so thank you, Ms. Prakia, for very insightful information technologies. I have a couple of words. Please, Professor Sangam.
Yeah, Dr. Locke, may I take this opportunity to welcome all the WEM alumni and also our distinguished guest. So I see a lot of WEM alumni, and I'm very happy to see their faces. And I hope all of you are doing very good despite these, COVID-19 pandemic challenges. Actually, this is a bi-weekly seminar. We have, started since last month, and the purpose of this bi-weekly seminar is to introduce the research that our students have been doing, and also to get the constructive comments and suggestion on the researches. Yeah, and also I thought of inviting our WEM alumni so that they are also aware what kind of research we are doing, and at the same time we can communicate with each other, right? So this is a good platform to communicate with alumni also. So I really thank you everyone to participate in this seminar, and I hope we can be in touch. Yeah. Thank you, Dr. Locke. Yes.
Yes, thank you, Dr. Sangam, for giving this very kind words and inspirational welcome to our alumni. I'm actually quite new, but I'm also an alumni over here in WEM. So I'm very happy to see all of my seniors as well who have taken their precious time to come and to participate in this bi-weekly event. So I'm really looking forward to more of the collaboration opportunities and exchange knowledge and comments from all of you. So thank you for your participation today. So with that, I would like to open the floor for the questions and comments for Ms. Prakia. Yes, please. So anyone, if you have any questions or comments, please unmute yourself and ask question directly to Ms. Prakia. Thank you.
Hello, Pakya. My name is 𝐂𝐯𝐿𝐥. Thank you for your presentation. I have a question on the slide number 8. For your ANN model, each node you have to define the function, right? So could you share us the function that you used for your model? Because there are many functions.
Yes, for the training of the function, I have used the hyper tangent sigmoid function, and to train, I have used the train LM function.
Okay, so have you tried some kind of the LU function that normally we use for the ANN model?
Actually, while choosing the function, I use the trial and error method. So I've tried different kinds of the functions, but as my data are in a non-linear relationship, so the function with the hypertangent sigmoid function works better. So that's why I use this one. I've tried it, but only for the trial and error method, like which function will functions better to train the model.
Okay, thank you.
Thank you.
Pragyat, I'm Yuru from WEM 2018. So
Yes.
thank you very much for a nice presentation. Actually, I have gone through this paper as well, published in Science of Total Environment 2 years ago. So I'm also working on this research related to ANN. So my question, thanks for your presentation. My question is do you recommend any function type like GRNN or whatever for the whole world? I mean, for the all river basins, or is it specific? Like from this also we understand that it's specific, case specific, right? Depending upon the climate zone, arid or semi-arid, wet zone, right? So based upon your experience, what is the conclusion for that? I mean, if you think about others also, is it the same like this?
And you want to know about in three among the three also, which one is the specific for the all three river basin?
Yeah, overall.
Overall. Okay. Actually, I compared 3 different kinds of the models inside the ANN model. One is feed forward, second is general regression, and third one is the multi-layer perceptron. Among all of the 3, the best one was general regression neural network, while for the main tropical and subtropical climatic zones, while for the Hariros River basin, it was a different, forward, backward to backward. Sorry. In this slide, we can see that the performance of the general regression neural networks are better than other models of the ANN. And my suggestion is that this model can be very work efficiently in the subtropical and tropical climatic zones, but for the arid zones, physical based models or other in the ANN for the ANN MLP and feed forward works better than GRNN.
Okay, thank you very much for suggestions. Right?
Thank you, Viru.
Yes. Is there any more questions from the audience? Okay, so thank you, Ms. Prakia, for very insightful and rich information. Actually, I also asked my students who are preparing the proposals to show today, so definitely they have learned a lot from the structure and also content-wise. So so maybe Ms. Prakia, maybe
Yes.
you can stop share.
Okay, sir. Thank you, sir. Thank you, everyone.
Yes, thank you, Ms. Prakia, again. And before we pass to the next presenter, may I request our distinguished guests and alumni to have a couple of lines and sharing to our students, our current WEM students over here. So any distinguished guests and alumni, if you want to share something, please unmute yourself and and share something to us, please. Thank you.
So on behalf of WEM, I'd like to thank Professor Sangam, Dr. Hu, for organizing this event. I think these events showcases our research component to the whole world, right? Because the world is moving and Professor Sangam is taking the initiative and we are seeing it through Facebook. And for the WEM, I would like to say that like a student who was studying structural engineering, she was motivated to apply for water engineering when she saw the WEM promotional video. So what can I ask more? She's a first class student, like 3.8 GPA undergraduate. She did her structural engineering undergraduate, and she was saying like, why didn't you share this before? So we don't need to ask about those things, right? Yeah. I'm really very content and very happy, right? So we get the opportunity to share like our status, what we are doing now. Even I was also in the chat box while I was looking Ms. Pragya's presentation. I'm very happy. There are a lot of high caliber alumni. I'm very junior one. So this is very good, and we will definitely participate in such kind of events. In future, please upload and update this in Facebook or email as Ms. Yani is doing. So Professor Sangam, thank you very much. Dr. Lu, thank you very much. Sorry for if I spelled your wrong correctly. And I'm from Sri Lanka, and we are representing the whole world. So Professor Sangam, you're doing a very great job. Thank you very much. Right? Thank you very much, everyone. And I wish all of you very good luck to everyone who is here.
Yeah, thank you, Mir. Yeah, I think we have very, good number of WEM alumni here. So if they want to speak a few words, I really would like to hear. Yeah. Yeah, I see Hira. Are you there? So can you update where are you and what you are doing?
Hello, Dr. Sangam. It's very nice to see all of you, and it was a very good presentation. I've been working on something very similar. I'm actually in Tokyo right now, in Tokyo Institute of Technology. I'm doing my PhD, and my thesis is related to the impacts of climate and land use change on hydrology. And I'm using the same thing, hydrological model and ANN for that purpose. So it's very good to connect with everyone after such a long time. And it's very nice. Thank you.
So thank you, Hira, for sharing this as well. Actually, I also got my PhD from Japan, from Kyoto University as well. It's just another part of Japan. So yeah, so it's really nice to hear from WEM. So, immediately when we hear the words AAT and WEM, it's to have a sound of family. That's quite unique. I think you have the same sense when you were in Japan. So I saw that we also have Dr. Putu over here. Dr. Putu, are you there? Maybe you have something to share with us.
Yes, Dr. Locke, but sorry, because of the connections problems, I cannot open my
yeah, sure.
camera.
Yes.
Yeah, thank you, Dr. Locke. So, thank you, Prof. Sangam, for the invitations, and hello, everyone. Please introduce myself. I'm the WM alumni 2015, and now I'm working in the university in Indonesia, the Bogor Agricultural University, and coordinate the graduate program for the applied climatology. So if you want to discuss related to the climatology, related to water resources, maybe we can talk about this topic. So thank you for the opportunity. So nice to meet all of you, the WM students, professors, and also the WM alumni. Thank you very much.
Thank you, Dr. Putu. It's very, really nice to hear from you again. Actually, Dr. Putu and I were on the same, of course, he was doing PhD and I was doing master, but we know each other for quite a long time. It's really good to hear from you, and then you're doing really well in your university as well. So I would like to invite Dr. Sajjan, another very distinguished guest, to share some of his thoughts with us today. Please, Dr. Sajjan. Hello, Dr. Sajjan, are you there? Okay, so maybe Dr. Sajjan is not available at the moment. So maybe I would like to invite Dr. Ram 𝐸𝐴 to share some of your thought when participating in our web today. If you are available, Dr. Ram. Okay, I think Dr. Ram Bahadur is not also have some technical problems. So I think, okay, so we will come back to our usual agenda. May I invite Ms. Parijat to start her presentation today. Thank you.
Thank you, Dr. Locke. Good morning, everyone. So I will be sharing my presentation. Good morning. My name is Parijat and I'm a recent WEM graduate. And today I'm presenting my master thesis on assessing climate change, land use change, and abstraction scenarios impact on groundwater resources in the special economic zone of Thailand. So today contents, I will be starting with the introduction, the study area, the methodology, result and discussion, and conclusion and recommendation from the study. To give you the background, I would like to say about the importance of groundwater. Groundwater is the world's largest freshwater resource available. As you can see from the figure on the right-hand side here, available freshwater is only up to 0.94%. And from that, groundwater contributes to almost around 96%. Groundwater is also used by different sectors, whether it's domestic, agricultural, or industrial. It's a reliable source, especially during the dry season, and less treatment is needed compared to surface water. And however, many studies has found that groundwater resources are under stresses, such as the climate change, land use and land cover change, and population growth. And from this stresses could come a severe impact, such as the groundwater abstraction, which could lead to land subsidence and saline intrusion, which is really serious and costly. And moving on to my study area, it's the TAC Special Economic Zone of Thailand, which if you look at the map here, it was announced as the Special Economic Zone along with 9 other areas by the Thai government to promote investment and trade. So from 2015, when it was announced, many new businesses occur in the Special Economic Zone. And to look at the groundwater in the study area, you can see that there's 3 types of well, which are drinking, agricultural, and business. The drinking is the most well found in the area. However, the allowable abstraction are found most in the businesses. So which will lead us to the overall objective of the study. The overall objective is to assess the impact of climate change, land use change, and abstraction scenario on groundwater resources in TAC Special Economic Zone in Thailand, with 3 specific objectives. The first is to project the future changes in climate, land use, and water demand in the study area. The second is to develop the hydrological and groundwater model in the TAC Special Economic Zone. The third is to assess the impact of projected stresses on groundwater recharge and groundwater resources. So the study area here is the TAC Special Economic Zone, which is located in TAC province in Thailand. It's border with Myanmar here. It's in the river basin called Salavin River Basin in Thailand, and also the trans-boundary river basin called Salween River Basin, as well as the aquifer basin called with the same name, Salween Aquifer River Basin. These are the maps of concerning with the study area. The first map here is the show the lower Salween River Basin. There's 2 climate stations from TMD or Thai Meteorological Department, 2 stations here with 3 river gauge from the Department of Water Resources. The groundwater well of business well, drinking, and agricultural well is shown here in this map. And lastly, the land cover map here, as you can see that most of the area in the TAC Special Economic Zone is agricultural area, and with some settlement or urban area along the middle here. These are the data collected and used in the study. There's data on socioeconomic, meteorological data, geographic, and hydrological data. For the overall objective, I first collected the data, and from that I could find the future stresses for the future climate, future land use, and future abstraction. And then from the first objective, it will be the input for the second objective, which is to develop the hydrological model and groundwater model, for which the output will be the projected recharge and projected groundwater resources for the third objective. For the future climate change projection, I have chosen 5 DCM from CMF6 model based on the suitability to the study area. From that, 5 model was bias corrected by linear downscaling, and after that, the model were evaluated by the statistical indicators, and 3 models were selected to represent the future climate. So for the study, there's 2 future scenarios that were considered, which are the SSP 2.5 and SSP 8.5, with 4 periods which will be mentioned from now on, which are the baseline or the observed period from 1981 to 2019, near future, which is from 2021 to 2050, mid future from 2051 to 2080, far future from 2081 to 2100. So this is the result of the statistical indicators for the precipitation, maximum temperature, minimum temperature, and the blue bar graph show the raw data of the statistical indicator before bias correcting. The orange show the value after bias correcting, and the green line show the desirable values. As you can see that all the models are performing better after bias correcting, but you cannot see visually which is the best model. So I ranked them, and the 3 best model found are CESM2, MRIESM0, and CAN-ESM. So from those 3 models, the future climate is shown here. The above graph is the annual climate values of precipitation, maximum temperature, and minimum temperature. The green dashed line is the observed data. The orange represent the SSP2 scenarios, and the blue line represent the SSP5 scenarios. If you look at the annual precipitation, you can see that it varies from years to years, but then there's no clear trend from the line graph. But if you look at the maximum and minimum temperature, you see that the range doesn't change much from the observed value, but the value are increasing. The average value is increasing with time. So from those values, it was averaged into the period, as you can see here, the baseline, near future, mid future, and far future. The line represent the change from the baseline. You can see that the rainfall for SSP2 scenario is increasing in near future and mid future, but for far future it is decreasing. And for SSP5 scenario, the rainfall is decreasing by around 3% in the near future and increasing in mid future and far future. And the same trend is found for both maximum temperature and minimum temperature, where it is increasing from the baseline for near future, mid future, and for both scenarios, with also increasing from period to period, with the highest increase found in the far future in SSP5 scenarios of around 5 degrees Celsius for both minimum and maximum temperature. Next is the future land use and land cover change. The data used for this is the 𝐒𝐨𝐴𝐶𝐳 climate satellite data. It was from 1995 to 2019. There's 7 land use type was considered here. As you can see from the trend here from 1995 to 2019, agricultural is increasing, and then from the last 10 years it is decreasing. For forest it was decreasing at first, but for the last around 20 years it is increasing. So from this data, it was used to project the future land use in the model DynaCLUE with 2 scenarios, which are business as usual and rapid urbanization. So this is the calibration and validation result from the Cohen-Papas index, and you can see that visually it is observed and simulated. It is showing a really good result, and the number here is also showing a good result. So from those setup, the future land use could be projected, could be estimated as shown here. The first, for business as usual, As you can see that the business as usual as is shown here in the orange line. Agricultural land is decreasing, forest is increasing, settlement is increasing, shrubland is decreasing here. And to point out the difference between these scenarios, you can see that the red area or the settlement area is really different between the two in the far future. So for the water demand forecasting, I have estimated for 3 sectors, which are domestic, agricultural, and industrial. From the result, it is shown that all the water demand are increasing from the baseline for both scenarios. Next is the hydrological model, which I use the SWOT model. There are 4 special input, which are the DEM file, the land use, map, soil map, and slope. From this, we could get the HRU for the model input. And with the weather input, the model is set up. And after that, the model is calibrated with SWOT cup. But while looking at the statistical indicators, these 3, and then after calibrating, we get the developed model. So here is the calibration result. I picked the 5 most sensitive parameters here, and then put back into the SWOT model. And then it shows the calibration result here, which pass all the minimum criteria for the satisfactory. So from that, the recharge is estimated. It is shown here, the overall recharge, that it is increased, all are increasing from the baseline, with similar result shown with 2 here, meaning the SSP2 scenarios. They show the same trend for the overall recharge, as well as SSP5, showing that it's increasing here. And from that, you look at the recharge zone. This is the baseline of the recharge zone. The lighter color showing less recharge per year, darker color showing more. So as you can see that the change is higher here on the lower part of the study area, while the urban area is decreasing, recharge is decreasing. So next, for the groundwater model, the study area has 4 layers of aquifer, which is shown here. The first layer and the second layer is in the same shape. This is the third and the 4th layer. The calibration was done in seasonal time step because of the data availability, and the projection is done in yearly time step. For the model setup, there's 2 boundary conditions. On the left-hand side here, there's a general head boundary condition, and on the right-hand side of the study area, it is a no-flow boundary. And also there are some other coverage setup, which was done to calibrate the model, and it has given a satisfying result. So the simulation result is as shown here. This is the water table change in the second aquifer, second layer. Since it's the most highest number of field is abstracting water from that layer. As you can see here, there's green area in the midline. This is the map of the baseline. Green showing that there's an increase in water level, and along the perimeter, it's showing a blue color, showing that the water level is decreasing. You could see that they all show the same trend for all the scenarios, but with higher values. You can see that purple or higher decrease is found here for all the scenarios, as well as the midline, whereas orange, the increase in water level is higher compared to the baseline. This is the flow budget of the aquifer. On the top left here is the baseline. The inflow is shown in green and outflow is shown in red. The darker color is showing the most contributing to the flow. So highest inflow is from the recharge and highest outflow of the aquifer is out to the river. From my observation, all the scenarios show the same trend of this inflow and outflow. And I have picked up the far future with rapid urbanization and SSP5 scenario to show here that all the order are still the same. And the graph on the right-hand side here is the variation of groundwater flow from each period in different scenarios. You can see that there's no clear trend in the period here. So for the conclusion, annual rainfall will increase by 0.5% in the near future, increase by 1.6% in the mid future, and 2.6% in the far future for the SSP2 4.5 scenarios. And for SSP5 scenario, the rainfall will rise by 0.11 and 3.35 and 5% in the near mid future and far future. For the annual minimum and maximum temperature, the temperature is increasing in the same interval, which for the SSP2 scenario increased by 2, 1, and 3 for the near mid and far future, and increase for the SSP5 scenario is increased by 1, 2, and 1, 3, and 5 Celsius. The forest area will increase in the near future, mid future, and far future. Urban area will expand along the main road, which was taught to the model, and overall water demand will increase over time for both scenarios. Recharge is projected to increase over time in different scenarios with similar trend for one climate scenario and same recharge pattern for one land use scenario. The water table along the border of the aquifer is decreasing while groundwater level in the middle is increasing. So, for the recommendation for management or implementation, propose some structural or non-structural water management should be implemented in the area where significant water level change is estimated, such as rainfall harvesting could be recommended for groundwater area where groundwater level is decreasing. And for recommendation for further research, groundwater simulation is done in yearly basis, which could left out some crucial information that may vary from season to season or month to month. So it might be good to look into that. And the current management of groundwater could be investigated for further improvement based on the projection of groundwater resources. And lastly, the soil impact of stresses can be studied to eliminate the effect of the combined impacts. Thank you.
Yes, so thank you, Ms. Parichat, for a very informative and interesting presentations. Actually, I learned a lot from this one. I'm also trying to familiarize myself with the water resources of Thailand. So with that, I would like to open the floor for questions and comments from the audience. So those want to have questions for Ms. Parichat, please unmute yourself and ask the question. Thank you.
Hello.
Yes, please, Sanjeev.
Good morning, everyone. My name is Sanjeev Neupane, and I'm currently a PhD student in Water Engineering and Management program in AIT. Thank you, Amy, for your very informative presentation. I really enjoyed your presentation and learned from it. So I have like two questions, not questions, but I want to learn from you. Like, how do you calculate the water demand, industrial and agriculture water demand for your study area? So did you only follow the literatures, or you do some analysis on that? And another is like, for future groundwater level calculation, how do you propose the groundwater abstraction? How do you calculate the groundwater abstraction? Yes, these are my two questions. Thank you.
Thank you, Sanjeev. The agricultural demand, it was estimated from IID. They use the method of from estimating the solar radiation and as well as rainfall. So I just abstracted from them. And for the industrial water demand, also from IID, they calculated based on the area of industrial and based on their plan of industrial development, as well as the development of the special economic zone. And for the application in the abstraction, I calculate, since the water demand doesn't separate the surface or groundwater, I just calculated it based on the baseline, on the ratio. So the ratio of groundwater use now, I didn't increase the ratio. So it might be some fault in there.
So you just like use the groundwater, like suppose if you get 50 water demand, then you just use the amount that is used in groundwater as demand and make it constant throughout the future?
I find the ratio of groundwater use for the baseline and modify that ratio for future demand also.
Oh, okay. Yes. Thank you, Amy.
Thank you, Sanjeev.
Any more questions and comments? Please, audience, please unmute yourself and ask. Thank you, Sanjeev, for your very critical questions. Actually, thank you.
Thank you, sir.
Please, I saw Yuru, you want to unmute and then ask questions. Please go ahead.
Parichat. Thank you for the nice presentation. So what I need to know is how did you couple the because sometimes when I read, I have used SWOT model for my master's thesis. How did you couple the mod flow and SWOT model? Like, did you use any computer codes, or or use the output of SWOT to mod flow? How was that? Can you briefly explain that? That's enough for me.
Actually, I just used the output from SWOT, which is the recharge and recharge zone. It was input as the recharge zone here, and recharge rate was input for different zone. That's all.
That's all, right? So no, you don't need computer coding. No computer coding. That's not. We don't need. Okay. Thank you. That you answered my question. Thank you very much.
Thank you.
Thank you, Nero, for your questions. Do you have any other questions from the audience?
Yeah. Hi, everyone.
Yes, please.
I'm Santosh Sungana, and currently I'm a research associate at WEM. So I'm also doing a similar kind of research. I'm trying to couple the recharge from groundwater recharge from SWOT to mode flow. So have you, I just wanted to know, did you take the recharge at the sub-basin level? You just linked the sub-basin ID with the, did you extract the recharge at sub-basin level?
I abstract at HIU with HIU level, and then manually draw the zone in the ArcGIS.
So you just first extract it at HRU level and then average it for a zonal level.
Yes.
Okay. Thank you.
Hi everyone, can I have some comments for AMI presentation?
Yes, thank you, Dr. Tun. Please go ahead.
Firstly, I would like to thank AMI for a very nice presentation. I think yes, you have done like a great job for your master thesis. I think it's quite like the integrated one. You do something from climate, subsurface with a rainfall runoff, and also run the model with underground water. So it's like I think very integrated one, very nice. So many job here, but I think I worked with you before, so I know about the research. Just one my comment about some recommendation. I think it's some kind of the transboundary aquifer. So I think after this master thesis, I think you can have I think you have something you can do more for like a transboundary aquifer, and so like a limitation of the groundwater abstraction, like Sanji he mentioned about how to estimate the groundwater abstraction, not only the ratio based on your baseline now, and also about because you in your prediction about groundwater level in future, somewhere is declining and somewhere is rising. So based on this, I think you can make the highlight for like the government or like the manager to know where should like can abstract more, where should reduce, and how much should be. So we have the better management in the future. So I think it has a lot of work in the research can expand more. So I think if you have time or maybe you continue with PhD research, I can you have you should focus on and continue this kind of work. Thank you.
Thank you, Dr. Tun.
Thank you, Dr. Tun, for very insightful recommendations. I think this is also applicable to all of our research, our students. So when you generate scientific findings, always take one more step to think about how you can translate that scientific findings into decision-making relevant, or we usually call it policy relevant, how we can help to make the decision makers to make better informed decisions. So that's also a very critical comments and suggestions. Thank you, Dr. Tun. So, so any other questions? Okay, actually, one of my colleagues, he followed us on Facebook, and then he has asked me to ask the question. So shall I? I think this is very interesting to show the power of social media today, that we can reach out to much further audience. So let me quickly check the messenger. Okay, so he has two questions to us, to Amy actually. So number one, he's curious to know how did you transform the, so what kind of functions that you use to estimate the rainfall input into your groundwater models? And that's question number one. And then the second question is he's curious to know how you estimate your groundwater recharge rate. So the question is coming from one of my colleagues is working as a lecturer in Vietnam National University as well. So yes, Amy, so please try answer, and then I will try to capture and repeat your answer to my colleague, Professor. Thank you.
Yes, sir. For the rainfall, it was estimated from the GCM model. So it was input as daily data with two stations here from the CMIP6 GCM model, from 3 models, which was the best model. So it was input in SWOT. And for the for recharge from the output of SWOT, it was given in monthly period, and there are many values for each HRU. So I just average it into this interval here, and use the mid value for each zone as the input for GMS mod flow.
Okay. Yes. Thank you, Amy. I hope that Dr. Long, who's following us on Facebook right now, has satisfactory answers from Amy. If not, I think Amy has put her email address, and then I can help to connect him with Amy. So Dr. Sangam, Professor Sangam, I saw that you raised your hand earlier. You have additional comments for Amy? Yes.
Yeah, Dr. Locke, I think this is not the questions, comments. Actually, I'm encouraging the WEM students, especially those who are preparing proposal now, to ask some questions or if they have any comments. No?
Yeah.
Yeah, I think there are many students, they are starting their proposal, right? Almost 17 students. So they might have some comments or questions or suggestions. Yeah, I highly encourage them to ask the questions.
Yes, thank you, Professor Sangam. Yes, I totally agree, and I encouraged some of four of my students are here. So Laris, and then Dana and Tadam also. We talked about how to formulate the research questions. So I think this is really a good opportunity to learn from your seniors. Of course, we're doing different research, but the practice and the protocols of both proposals are pretty much there. So I think this is a really good opportunity. So may I invite Laris? So you have any questions for your senior?
Hi Amy.
Hi.
Yeah, it was quite a good presentation. What will be my question? I think I'm working on the objective as well.
Laris, maybe you can increase the volume a bit. I think we have hard time listening.
Okay. Yeah. Is it audible now?
Yeah, it's much better. Thank you, Laris.
Actually, I don't have much questions because I'm more of observing right now.
Yeah.
So are there any advices that you can give throughout the when you're doing your thesis? It's more of a general question.
Yeah.
If I talk about the proposal period, maybe to look into the details of your work. Really look into the details, because when you start working, problem pop up, and so you should really plan your work as detailed as possible and start working as soon as possible.
Yes, will do. And anyway, in terms when you're doing your proposal, if there are any doubts, usually when, for example, you lack some data or anything that comes in your way, what do you call this? What can you advise me or everyone else that are doing their proposals now?
Usually during proposal is the time you most what do you call communicating with your advisor the most. I try to go meet him every other week or almost every week to solve the problem, or you can also ask your senior or some researcher in WEM. That could also help. That what helped me.
Okay, we'll do that. Thank you so much, Amy.
Yes, thank you, Amy, for a very, I would say, very practical and critical as at the moment advice. So yeah, we in our group we've been trying to have a weekly meetings to troubleshoot all of those doubts and things. I think it's also very good advice to all of the junior students who are preparing the proposals right now. So any other questions or comments from the audience? Yeah, I think if not, then I would like to again say thanks to Parijat and Pragya for spending the time and present a very insightful, inspirational presentations today. With this, I would like to say thank you to all of the audience who have participated today. So as a last part, we would have a group photo. So maybe can I request yes, stop share. And okay, so we have Mr. Roel over here. So I will pass the floor to Mr. Roel to prepare everyone for the group photo session. So may I request everyone to turn on your video so that we can have a group session. Since we are having a lot of participants today. So there will be several panels just to take photos. So please stay with us. So Mr. Roel, maybe you can instruct us on when to smile and everything. Okay, please, Mr. Roel. Thank you.
Hello, good day for everybody. So please look to your camera and smile. So we have 3 view now. So I'll shot for this view. Okay. Second. And third. Okay, thank you very much for everybody.
Okay, thank you, Mr. Roel.
Yeah, Dr. Locke, your microphone is muted. Yeah.
Sorry. So I would like to say thank you to Mr. Roel, our virtual photographer today. And I wish everyone a restful afternoon. And okay, so before we stop, I have 2 announcements to make. As we already know that we have reached 11 presentations. So it is now time for a poll voting for winning of the best presentations. So you'll be expecting a Google Doc poll voting. So please, so we have around 10 days to vote for your favorite presentations, and the best presenter will be eligible for a coupon of 2 drinks, where you can invite your friend to either Hamprun or Intanin for either research or non-research is totally fine. So the offer is will be there. So the links for the poll will be sent to your email. So do look out for it. And finally, the another announcement I would like to make is about our next presenters. Just give me a moment. Okay, so for our next seminar series number 6, we will have the presentations. First will be.
He's not agreeing to.
Yes, so the first presenter will be Ms. Predith Grace, and then the second one will be Mr. Chayupon. Will be our next presenters, and then we'll be meeting again on 7th of July. So thank you, everyone, and have a nice day ahead. Thank you. Bye-bye.
Okay, thank you, everyone. Okay, please stay safe and stay healthy. Bye.
Yeah. Bye-bye.
Bye-bye. Bye.
Bye-bye.